Right. Shh. Dan. Question 1. This algebra bit, so the first bit just says, simplify the expression 1 minus x over x squared minus 3x plus 2. All we need to do, we know what to expect with these, so we need to factorise the bottom line of the fraction. You remember in Core 4 you're supposed to be looking back and being asked anything from anywhere on any of the other modules, so factorising quadratic, well there you go, that's a nice bit of Core 1. Would have to be 2 and 1, wouldn't it? And they'd need to both be negative. And there we've got it factorised. Now, hopefully at this point you do spot that we've got a common factor, but you may need to do something with it first. So what we're going to do first is, well actually, there are a couple of ways you could go about doing this, but I think we'll take the top line and we'll make it negative. Because that would be the same thing, wouldn't it? Because we've got minus x plus 1. And so now we've got x minus 1 as a common factor, and we're left with minus 1 over x minus 2. There are loads of ways you could have done that. Actually, when I did this, I thought an easy way to do this is if I turn both of these fractions round, that's like multiplying the bottom line by 1, because it's multiplying by minus 1 twice. So that would be 2 minus x times 1 minus x. The 1 minus x cancels, and I wrote it as being 1 over 2 minus x, which is the same thing, and probably a slightly nicer way of writing it. But however you present that, it was getting to that point that mattered. That's great, that's 2 marks. Now the next bit, part 2, has us dealing with x plus 1 minus x minus 1, x minus 3. Take away x minus 5 over x minus 3, x minus 4. There's a slight danger here that we see the fractions and we think this is partial fractions, but it's actually nowhere near as complicated as that. Partial fractions is about splitting things up, isn't it? And we're actually supposed to be simplifying this and bringing it together. So what we're interested in is there a common denominator? Well, we've got x minus 3 appearing in both fractions, so if we make the denominator into x minus 1, x minus 3, x minus 4, then that would be the smallest thing that both of these fractions go into without a remainder. The first fraction, to make it look like that, we've multiplied the bottom line by x minus 4. So we need to multiply the top line by x minus 4 as well. The second fraction, we've multiplied the bottom line by x minus 1 to make it look like that. So we must multiply the top line by x minus 1 to get to that point. Does that make sense? So that's putting it over a common denominator. It's like that thing of, when you've got a fraction over 3 and a fraction over 4, you put it over 12, because that's the smallest thing that 3 and 4 go into. So that's the smallest thing that both of those go into. It doesn't feel particularly sophisticated, but the only thing we can do at this point is to multiply out the top line and collect together like terms. We've got x squared minus 3x minus 4, and we're taking away x squared minus 6x plus 5. Have I done that right? I think. And if we collect together like terms there, the x squareds will cancel out. We've got minus 3 minus minus 6, so we've got 3x. We've got minus 4, take away another 5, so minus 9. And this is quite a nice moment, isn't it, when you realise that there is another stage of something quite nice going to happen here. Because if we factorise the top, it's 3 lots of x minus 3, which also appeared as a factor in the bottom. So this time, let's see, the x minus 3 cancels out, and we're left with 3 over x minus 1, x minus 4. And that's that. And that, if you think, for 6 marks, 2 marks and then 4 marks, that's a fantastic way to start a paper. You could have hoped that that's what happens in a couple of weeks' time. You get a question like that. There we go, and that's maths.